Hello guys, welcome back to Tronic Xnor, and we are still on our series to make the 8-bit logic unit, and the circuit is continuing to grow. You can see a lot of jumpers are coming from the logic gates up there and down here to this single IC, which has two 4x1 multiplexers like this, one on top and the other one on the bottom. So we already finished the one on top, which had data lines from pin number 10, 11, 12 and 13. Then we connected the two multiplexers together via the enable pins to get S2, which was our our third select line that was enabling us to make this an 8x1 multiplexer rather than using just 4x1 multiplexer. So since 8x1 it should have 3 selects, so that's why we needed to know how to connect the enable pin together using these transistors. You can see them here, yes, in order to get that select line. So that video is already there. So for new viewers, you can just go to my page and just check how we have been coming along. So don't get confused, don't get frustrated. It's not very complex. If you followed me from the beginning of the videos, you'll just see that it is just simple, only that we are adding one bit at a time so that we don't get lost. Yes, that being said, so today we were to add another gate to our 8x1 multiplexer. I'm going to call it 8x1 because it's an 8x1 right now. Yeah, so we already added the first input to the other multiplexer, which was Xnor, and we gave it the code 100, and it's this one here at pin number 6. Then today we have added at K1 pin number 5, we have added 101, which will be an Xnor gate. Yes, simply if you have this IC, if you have this integrated circuit, it's a 74HC86. It has a couple of Xnor gates. If you just pass the output of A and B to a NOT gate like I've done here, you can see this purple jumper, this one. If you just take that output of A and B, then take it to a NOT gate, the output will be definitely an Xnor gate. So the output of Xnor, take it to an inverter, you get an Xnor gate. So that's simply how you can just make an Xnor. If you don't have an Xnor, there are plenty of ways to make. I think you need some OR gates, some AND gates, and yeah, and you will be good. So today we have made an Xnor gate. Yes, and this is the truth table of an Xnor gate. If I can just, yeah, like that. This is the truth table of an Xnor gate. So when the inputs when the inputs are alike, you'll get a 1 output. When the inputs are not alike, you'll get a 0 output. So if this 0 0, you'll get a 1. If it's 0 1, because they are not alike, you get a 0. If there's 1 0 not alike, you'll get a 0. But there's 1 1. If there is 1 1, you get a 1. It's basically the opposite of the Xnor gate. Remember the Xnor gate, we said that when they are alike, you'll get a 0. You can see if they are like 0 0, you get a 0. If they are like 1 1, you get a 0. But if they are not alike, you'll get a 1. So if you can see, this is just basically the opposite of the Xnor gate. So that's what we expect our circuit to do. I'll just place this here so that we confirm and check if our circuit is performing as it should be. Just like tilt like that, so that I get some room for the demonstration. So I hope you can see the table well, so that when we demonstrate, we'll be checking our truth table to ensure that it's working that way. So let me power up my circuit, and it's on, we'll go straight to our demonstration on Xnor gate. We say that Xnor, the code is 101. So that 101, we place it at our select line. That's 1. Then the middle one is 0. Then the other one is 1. So that's called 101. Yes. Okay, and immediately you can see the output LED, green LED is on. So let's check about that. So 00, yeah, the inputs A and B are 00, so that's why there's a 1. If either of the input, if they are alike, you'll give a 1 output. If they are not alike, you'll give a 0 output. So let me place this 1 and check. It's 0 because they are not alike. One of them is 1, the other one is 0. So let me try turning this one on, turn the other one on. Yeah, get a 0 output. Why? Because they are not alike. They are not alike. This one is 1, this one is 0. And when both inputs are 1, we expect to get a 1. Yeah, because they are alike, both inputs are on. So that's basically how an Xnor operates. When they are alike, you'll get a 1 output. When they are not alike, you'll get a 0 output. So let's try that again. Not alike, 0 output. Turn this off. Turn this one on. Not alike, 0 output. They are alike, 1 1. You get an output. So that's basically how the Xnor gate operates. Yeah, it's basically the opposite of the XOR gate. If you can remember the XOR gate, when they were alike, you'll get a 0 output. So let's put the code for XOR gate and check the difference between the Xnor and the XOR. So the code for XOR gate is 100. So we just basically turn this one off like that, and now it's at XOR operation. It's going to perform XOR operation only. So let's see. When they are alike, you'll get a 0 output. Is that true? 1 1, you get a 0 output. Let's put them at 0 0. 0 0, you'll get a 0 output. Let me turn this. You get a 0 output. 0 0 0 1 1 0. Then when either of the inputs is 1 and the other one is 0, you get a 1 output. Let's check. If they are irregular, we'll get a 1 output. Yeah, that's true. Let's turn this one this other. Yeah, that's true. Then when both of them are on, you get a 0 output. And when both of them are off, you get a 0 output. Yeah, so that's the XOR. So that's the difference between the XOR and the Xnor. They're just basically inverted. This is just the inverted of the XOR gate. So yes, that's what I wanted to show you for today. Next up, we are going to connect not A, and the other one we are going to connect not B, and then we'll be through. If you can check, we are just remaining with two. You can just see them in the IC, just 2 pins to finish up our IC, which we made it to be an 8x1 multiplexer, and the whole circuit will be the 8x1 logic unit that we have been doing in the couple of weeks. Yes, so we have one. This is the binary of 0 1 2 3 4 5. Then we are going to go to 6 and 7, and that will be the final. So 7 code will be like this. 7 will be looking like this, 1 1 1. So all this select should be on 1 1 1. That will be 7, and that will be the final select. That will be the final code, yeah, for our 8x1 multiplexer. So thank you very much, guys, for watching. Please subscribe to Xnor, where we do fun stuff all day, all time.